Anybody familiar with the command line interfaces? You know, command line CLI tools? Raise your hands, it's okay. Okay, that's great. This is, oh yes, this is a lot better. Yes, this is basically a live stream of my brain signals in the terminal. This is a command line application that I wrote in Node.js. It's JavaScript from the ground up. And you're seeing 14 different channels of my brain activity. You see the battery. There's also a gyro in the top right corner. I'm pretty sure you cannot see it, but you have to believe me. It moves when I move my head, so it can also track head movements. Yeah, so apparently it's at least working a little bit. Then we can go to the presentation. I'm really happy to be here today, so thank you for joining me in this huge sea of options. I kind of believe you made the right choice by being here. This talk is called console.log brain. Who is a JavaScript developer here? Any JavaScript developers? 1, 2, 3, kind of. Don't, yeah, it's okay to be a JavaScript developer. Don't be ashamed. Okay. So console.log is something developers use almost every day, almost daily, to debug their code, right? And I wanted to present a way to debug the brain by using console.log, and hence the title of the talk, console.log brain. I'm Armagan Amcalar. I come from Berlin. I work for a company called UNU GmbH. We're building mobility solutions for the future. We have an electric scooter that's like a Vespa, but with batteries, and we're building the scooters and a lot of other fancy stuff with the future of mobility. I'm also a founder in a voluntary organization called Lonja, which is a software craftsmanship school for women, because we believe there's a huge discrepancy in between genders in the industry, and we try to kind of alleviate the situation. I'm pretty much active on GitHub. I have a lot of open source. Actually, every single line of code I write for my own is open source on GitHub. I have libraries that range from front-end libraries to back-end libraries to microservices to platform as a service to audio libraries to brain signal processing. So anything you may want to tackle in GitHub, the repositories are there. I also do chatbots and stuff. So we can collaborate on a lot of stuff if you're interested in open source programming. Okay. So this story basically came into fruition when I asked myself the question, what is the ultimate hack? I asked that because there is a meetup in Berlin called Hack and Tell. So hackers around town come together and present their hacks each month. At the end of each month. They're not security hackers, they're not computer hackers, they're real-life, real-world hackers. So they take a chair and make an IoT device out of it, for example. This kind of hacking, or hacking voting machines or public phones, that kind of hackers. So I was looking for the ultimate hack, you know, what can I present there? And it's kind of a competition. At the end of the day, at the end of all the presentations, people vote on the talks. Oh, and by the way, this conference values a lot your feedback, and there are a lot of feedback mechanisms. Please share what you think about the talks, and especially mine. Even if it's good or bad, please share it with the conference so that we can improve. But at the end of the day, there is a competition, and people vote on the talks that they like, and they give the winner a trophy. So I presented there once, I won it. I presented there twice, I won it again, and I presented there the third time in a row, thinking, you know, if you win it 3 times in a row, maybe they will give it to you, much like the World Cup. If you win the World Cup 3 times in a row, they give it to you, or they did. So they said, no, we won't. You have to bring it back. But I was looking for the ultimate hack to win it in a third time, and I came up with the idea of the brain. This is Elon Musk. He set up a company called Neuralink last year. He said, we are about 8 to 10 years away from a high-speed highway between a brain and a computer. So we'll be able to decipher what your brain is generating in terms of signals, and we'll be able to put it to good use, meaning people will be able to use it to communicate with each other, communicating through brain signals. Now, you know, he's a little bit optimistic about everything. His deadlines and his projects, they're very optimistic. This project is also a little bit optimistic, you know, 8 to 10 years, but I'm going to talk about that in a little bit. Right after that, Facebook had another conference, and they said, you know, we're going into BCI. We're going into brain-computer interfaces, brain signal processing, and this is an actual slide. You know, they had a huge presentation, and they said, you know what? So what if you could type directly from your brain? And this is what they're trying to do, to eliminate voice, to eliminate the thumb sores that you have when you type messages, so that you can directly communicate to your phone or a computer, and you know, you can talk with your friends only by using your thoughts. And they are a little bit realistic, a little bit more realistic than Elon Musk. They said, you know, this technology is a little bit far away. Maybe 20 years will be there in 20 years, which was kind of an okay-ish estimation. But, you know, developers are really bad at estimating stuff. This is me and my friend. She's my best friend over there, making kind of fun of me. This is a picture from 8 years ago with a EEG cap, EEG headset, and some electrodes. And here I'm getting ready for a live demo of a brain-computer interface that lets you type with your brain signals. This is a tweet that I did 8 years ago in 2010, kind of 8.5 years ago now. And it is the URL of my research. So I'm actually working in this field, or I worked in this field 10 years ago as part of my master's thesis, and the topic was typing with brain signals. So I typed this only by using brain signals, and I used Twitter's API to submit it to Twitter. So no hands involved in the production of this tweet. It's very pure. It's directly from my brain. And so, of course, the point is people are doing this for several years. Of course, I wasn't the first to do that. And we are pretty much at the same spot where we were 8 years ago. So there are some minor improvements, but it's not going to get, you know, super fancy in the next 10 years. Maybe this will happen in the next 50 years, and hopefully we'll be able to see it in the near future. But this is an ongoing topic. So I thought, you know, I can present this, my master's thesis, which was implemented in MATLAB, C++, and C#, because it's a scientific research, right? It's a lot of machine learning involved. I said, as a challenge, I can implement all of this in 2 weeks in JavaScript, all of the machine learning code in MATLAB, and I kind of did, but more about that later. So a little bit about brain signals, what they look like. This is the first ever instance of a brain signal recorded. It's from 1924. I guess the picture is from 28 or something. I'm not sure. But 80 years ago, a crazy German scientist called Hans Berger was working on this, EEG, electroencephalography, or brain signals again. And that's his real name. Hans Berger is a real name. I know it's a very generic German name, but this guy was real. And he was very, very famous in all kinds of physiological stuff. And he said, you know, I can read some signals, electrical signals out of the brain, and I can find some sicknesses or causes of some sicknesses. You know, previously people were burning, but then discovered that they're having problems with their brain. So he was diagnosed this and then kind of fixed this. And he came up with these drawings. Obviously, they're not very high quality. They don't have a lot of resolution or depth. But he was ridiculed. So he was cast out of the academia for some time, for almost 10 years, because people said, you know, you're a liar, you're a charlatan. That's impossible. Nobody can get electrical activity from the brain. And I guess in 6 to 8 years, some other researchers tried his stuff and said, no, actually this is working. And after 10 years, they kind of gave back his reputation to him. So this is how we discovered the world of EEG. This is how it looks now on a white background. It almost looks like noise. You know, that shh sound you see at the end of MP3 tracks or old cassettes. Anyone knows what a noise is? Yeah, it looks like this. That shh sound looks like this when it's put into the time domain as a time series graph. It's almost impossible to decipher or understand anything from this because there is, you know, the mains electricity, 50 hertz, 60 hertz, that is interfering with your brain signals, and your cell phones and Wi-Fi and radio, everything around us is basically interfering with our signals, our brain signals, and it's very hard to, this is on the order of microvolts. So a regular battery is like 1.5 volts that you buy from the supermarket. This is like 1/1,000,000th of it. So it's almost impossible to detect these among all the noise that you have. That's why this kind of couldn't make it out of the lab kind of yet. And yeah, I can actually show you. I already did, but hope it's working again. Yeah. So, yeah, this is a series of brain signals. I hope it was a little bit more visible. It was really fun to do this as a CLI tool, by the way. You don't need any user interface or GUI for this. Just go into a machine, SSH into any machine that is connected to this headset, and you can run this. But the point is, it's almost impossible to find any patterns by eye. You have to apply a lot of machine learning to get anything that's useful out of these brain signals. And yeah, I don't know if you can, no, but you can't, right? If you could see the last 2 rows, the only thing that's visible is when I blink my eyes. When I blink my eyes, you see peaks in the signal, and that happens because I'm using a lot of face muscles when I blink, and your face muscles generate electricity as well, and that also interferes with your brain signals. So in order for this to be useful, you shouldn't be talking, you shouldn't be walking or doing any physical activity. You shouldn't be smiling even, or you shouldn't even be blinking. How about that? So, we have some algorithms to remove the blinks from the signal because it's too hard. Okay, let's go back. So this is me. Oh, yeah, we don't have sound, do we? I don't think so, but it's all right. This is me sitting at home working on an experiment to basically replicate what I did 8 years ago with research-grade stuff. And this is all running in JavaScript, although, does anybody hate JavaScript? That's perfectly okay. You can hate it. Yeah, there's one there. Perfect. I also hated it at some point. But I now think it's the most powerful thing in the world. And I'm here to kind of prove that to you. And I do that by showing you this. This is a matrix of letters and numbers. And I'm trying to type the message hello in this video. So I'm only staring at the screen. It's kind of a boring watch because, as I said before, you're not allowed to move or do anything else. So the only thing that's changing in the scenario in this video is the screen. So what I do is there are some blinking letters, they're flashing randomly, and I'm focusing on the letter that I want to type, and I'm counting how many times it flashes, and somehow the machine learning algorithms detect that and convert them into letters. So did E appear yet? No? Okay, so we're waiting for the E to appear. So E is over there, so 1. Obviously, it's not the first one, but 2, 3. I'm counting whenever it's lighting up. And there is a special signal in the brain that is produced because of this, because E is, and you see that the machine finally got it right, that I want to type E. There's a special signal in the brain called P300, which means positive 300. And it is a reaction to the stimulus. So there are flashing stuff that some of the letters you're interested in, some of them you're not interested in. I'm only interested in which letter right now? L, yes, perfect. I'm interested in L, so I'm counting L, and obviously it's a rare event, right? I have 35 other stuff that's flashing. I'm not interested in those, I'm only interested in L. That's a very rare event. Therefore, whenever I see L, I see like, yes, this is it. This is the one that I'm waiting for, and I'm counting it, I'm incrementing it. I have an internal counter. I'm very good at counting, up to 20 or something. And then the machine learning algorithm detects that positive peak in the signal that occurs 300 milliseconds after I receive that stimulus, after I receive that surprising event, and kind of make sure that I really want to type it, and I'm not making any mistake. I'm not looking into any other letters. And in the end, it displays it to me as the second L. So I know it's a little bit boring, but let's watch for another 30 seconds or something. So that we see the end. Yeah, again, this is all in JavaScript, including all the code that is required to get the signals from this device and to process it to make this happen, and the UI. So yes, I see I have a hello, and this was a very prolific moment for me because I was kind of accusing myself for leaving academia and research and going back to web development. And 8 years after, I was still able to come up with some results, and that was really good. That was really good because I was like, okay, I'm not dead, and actually my programming skills improved so much that I can open source this code. And I did. It's also open source on GitHub. You can find all the source code for this. I was too ashamed to share my previous code, my research stage. It was horrible, but now it's very. It has a very nice architecture that's kind of supports plugins, so you can expand to other headsets or to other algorithms. So you can build with that. But how does this thing work? That is the biggest question. We have 100 billion neurons in our brain. 100 billion neurons that are firing every second, that are generating electricity. Can you get that number in your head? 100 billion. It's like the number of stars in our galaxy. How does it even fit into this thing? But apparently it does. We of course don't know the exact number, by the way. But there are some chemical reactions due to an exchange between the neurons, and they kind of create a potential difference, which is another name for voltage. So they exchange potassium and sodium, and due to that exchange, there's a voltage that occurs in between the neurons. I have 14 electrodes on my head right now. The best kind of headsets have 256 electrodes in them, and it's like 400,000 neurons per electrode, which means you basically get no signal, right? You get the average of them. You get the average of that 400,000 neurons in a single electrode, which is kind of nothing. It's because if you think of it as a vector, somebody is pulling to -1, somebody is pulling to +1. When you add them up, you get 0. So you don't know that they are two separate things. The thing is, we have another mode of operation. We can open the skull and put the electrode inside as an invasive operation, but it's not very healthy. I think governments also don't allow that because the chance of death is pretty high. So you have to be terminally ill for the government to allow that. You cannot say, oh, please open my skull and insert some electrodes, because half of the time you will die. And you have one chance, right? So the thing is, we don't know how it works. We have very slight idea of its output. We can observe it, and we can build on top of that, but we don't know how it actually works. But in 1988, two researchers came up with this paradigm. It's called the oddball paradigm, or the surprise element paradigm. And they published the first paper on this, coming up with a brain-computer interface that had 2.3 letters per minute performance. 30 years ago. Okay? We've been doing this for 30 years. And the state this is in right now, the state that I could get to, was like 20 letters per minute. So it's still very slow. It's still not very high speed, and it's very stupid to look into a screen with flashing letters and stuff. It's not the most user-friendly thing at all. That's why this requires a lot of development plus UX. So anybody interested in user experience here? Oh yeah. So we need your help. This field needs our help to find better ways and better paradigms of using brain signals to type, basically. Okay, so I already talked about the flashing letters. But the machine learning task is as simple as separating the black signals from the red signals. The red signals are the ones with the space in between, and black is the continuous one. So the black one if you see, this is the 300 millisecond mark. After that, there's a peak. So if you can detect this peak, then you can let people talk. And this kind of has a peak as well, the red one. Of course, because as I said, it's almost like noise. It's very hard to differentiate these things. And you should keep in mind that this is an average of 20 different signals for black and 20 different signals for red. So some of the red signals, some of the rejected signals, or should be rejected signals, also they have peaks because your focus also diverges in between letters. And again, we don't know how the brain works. Maybe you thought of something very alluring, very exciting, and you had another response there. Or you blinked, right? So this is as far as we can get. If you can crack this, you can make this work. Okay, where do you start? Anybody written any JavaScript before? You don't have to be a JavaScript developer to write JavaScript. Okay, I hope this code is somehow familiar to you. I can read it. This is an open source package on NPM, so you can directly install it. And if you have this headset, you can directly start streaming to the console. It reads as constant mind requires widths. You do mind open, so you open your mind. And then you do mind.read. You read your mind to the console. This is the actual 3 lines that you need to get started with this. And all you will see at the end is just a list of numbers, unfortunately, because that's what it's nothing fancy. You'll get a stream of numbers, and then the rest is up to you. You decide what you want to do with it. You will get a number for each of the electrodes, unfiltered, with a lot of noise inside, with a lot of noise of the environment, with the main electricity noise, and you have to filter them and make it work. So I also already demonstrated the brain monitor, which is also available on GitHub. This is this CLI tool that gives you all the raw signals from the headset, filters them a little bit so that you can display it here. Of course, there's a nicer version of this that works with an actual user interface, a GUI, so you can get more high-quality signals. And the source code for the P300 oddball paradigm is also available on GitHub. So you see, this is a little bit different. Previously, the letters were flashing. Now I have colorful boxes. Why do you think I'm doing it? Anybody? Come on, you can just shoot something. Why is this different? That there are some, colorful boxes instead of flashing letters, please. Yes, so the answer was the signal to identify color could be a different one from counting. That is some assumption that we are trying to figure out. Of course, we don't know the answer, but the idea is we know this occurs when people are surprised, okay? Flashing white is not surprising after a certain point. So what if we change the color? What if we block the letter? Is it surprising enough for people? And that's why I say this is a UX issue. Like, there are a lot of stuff here that where you can help with this. And it's why, it's also open source. The technology stack is all JavaScript. JavaScript on the back end. It has an Electron wrapper. Anybody heard of Electron? Yeah, it's used for desktop apps. So Skype, Slack, and a bunch of other desktop applications run in Electron. They're actually JavaScript applications. We do the machine learning in Node.js, and we use Vue.js in the front end for building all the user interfaces and that flashing thing. There is a neural network library called Brain.js that we're using for neural networks, but then there is another custom classifier that I wrote for machine learning. Back in the day, 8 years ago, I translated it kind of from MATLAB to JavaScript. Disclaimer: don't try it at home; it's a horrible experience. One single line in MATLAB is like 1,000 lines in JavaScript, and making sure that it works exactly the same with floating numbers of matrix multiplication of millions of records. It's a horrible experience, but I could crack it, so it works. And there's one thing. Everybody knows what an eigenvector is? Eigenfunction, eigenvector, eigenvalue? Okay, it's a very special function that doesn't have a concrete answer. It has multiple answers in linear algebra. Okay, so the methodology changes and the results change based on the answer that you find out. And there are a lot of answers for any given eigenvector problem. MATLAB is very good at that. And all of the libraries that I found in JavaScript is bad at it. So I implemented an HTTP server in MATLAB. It's used for scientific computing, but I put a web server there. You know, the roles have changed now. Node.js is doing the machine learning and algorithms. MATLAB is doing the web server. And it just calculates the eigenvector of a given array. So you pass the vector, it gives you the eigenvector back. And that's all it does. And that's how we could get good accuracy and performance out of this problem. The ones in JavaScript didn't work, unfortunately. So, how do we do it? We grab the raw electrode data. I'm running out of time, by the way. But after me, there's a coffee break, so I'm planning to steal you for a couple of more minutes, maybe, after the talk. So we grab the raw electrode data. We filter between 1 and 12 hertz. We visualize it. By the way, you can patent this. You cannot. I published it already in various academic conferences. But this is kind of the industry best way of doing this. So, and I'm going to share the slides if you want to get into this business. You normalize it. You remove some samples that you don't need, and then you apply machine learning and expect it to work. There is a lot of filtering and a lot of tweaking to make sure the signals represent similar stuff, because you know, your brain signals change even in the course of hours. So if you still keep the same headset on in the morning and you make a recording and you make a test, in the evening or in the afternoon, your brain changes like 20%. The signals change, the frequencies change, the amplitudes change. So it's really hard to unify them, and this is an effort to do so. Okay, the conclusion is, most people think JavaScript is not good at math, and it's powerful only to parse JSON APIs. And what I claim is it's also good at parsing your brain's API and making this happen, you know, brain-computer interface, all in one single language. Good luck with other languages trying to do the same thing. That's all. Thank you for listening to me. Great. I don't know if we have time for questions, but I would like to.
Please show the previous slide again.
This one? Yeah. Oh yeah. Yeah, please tweet about it.
Yeah.
Please.
So, how much does it cost?
Yeah, we have the microphone. Does it work? Or I can repeat the question.
Yeah.
Okay, please.
Just out of curiosity, how much does it cost?
This headset is a consumer level headset, and it costs around 700 euros, $700. But obviously it's a little bit better than a toy, so you cannot do real scientific stuff with it. For that, you have to pay like 20,000 euros or something, which is horrible. That's why the field doesn't progress. Anyone else?
So cheaper than a Mercedes.
Yeah. And you can save people's lives with it, which is really good. Any other questions?
Why did you choose JavaScript?
Okay, the question is, yeah, the question is why did you choose JavaScript? Because previously I implemented it in a professional context with MATLAB, C++, and C#, and it was not fun to do so in 2018. It was fun to do it in JavaScript and to prove to the world that it's the most powerful thing ever. You know, one single language that can do anything, any of your dreams, is the best perfect solution. So just learn JavaScript and you're good to go. It was a challenge. I did it for a competition. I did it to win the competition. And I did, obviously. They gave it to me for the third time, but I had to take it back. And they said, don't come again. I was like, okay, sorry. Any other questions? No. Okay, I'm here for the rest of the day, so we can meet afterwards in the coffee break. Thank you for listening to me again.
Thank you.